deceleration, the ability to stop on a dime, and the foundation of game-changing change of direction is no longer this mystical thing that we say is important, but haven't had a way to both efficiently and effectively test and train it. So let's get into how to and best practices for taking your deceleration to the next level. So first, what is deceleration? Why test it? And just overall understanding what it is. So deceleration is the braking phase of change of direction. So from Damien Harper's work, you have two phases of a cut. The braking phase, the first few chops, the most forceful steps when you're taking away the most speed. And then you have the cutting phase where the athlete's speed is reduced to a safe enough amount to where they can just change their shin angles to then change direction and go in a different direction. So deceleration is the first part of a cut when you take away the most speed. And being able to quantify it, being able to compare and contrast deceleration by itself versus cutting by itself versus putting it all together, you can identify what is the weak link in an athlete change of direction, consequently improve it, and improve all of their change of direction. So this research comes from Damien Harper, like I said, and the acceleration deceleration ability test, or ADA test, was very simple. Sprint 20 meters as fast as possible, and then measure how long it takes to completely decelerate and stop. And then in the study, to make sure that they completely stopped, they had to kind of backpedal once they were done decelerating. So visually, what this looks like: sprint towards the line, slam on the brakes at the last possible second, take a few back pedals back. And then here's a video of a soccer club in Europe doing some deceleration testing, doing the ADA live, and simple and effective. Run as fast as you can, slam on the brakes. So how to start with your ADA deceleration testing journey. So the distance, 10 yards, 10 meters, is a fantastic place to start, where it's far enough to where the athlete can get a decent amount of speed, but it's not too far to where they could hit something maybe beyond what they're capable of decelerating from. So you have where the athlete is starting, and then you have cones or a line 10 yards or meters away, and that's where they're going to touch their foot and then take a few back pedals. The load on your 1080 sprint is going to be 3 kilos. It's light enough to not really interfere or change their mechanics or pull them out of position, but also to keep the data and the line they're attached to kind of stable. And this is going to be in an assisted direction or towards the machine. And the reason for this is if the athlete was being resisted or running away from the machine, the 3 kilos would be holding them back, so they're not hitting as fast of a speed as they potentially could. So if they're running towards the machine and the load is helping them out maybe a little bit, then the athlete can self-limit their speed or will self-limit their speed to what they're kind of comfortable with. So they have the ability to pick their top speed when they go into the deceleration versus their resistance. Even if they're running as hard as they can, they're still being held back a little bit. And for the intensity, it is okay and recommended to on-ramp, or just because you can go all out or it will be all out doesn't mean that you have to start at 100% kind of right away. So you can start 10 yards, 10 meters, 3 kgs, 50% effort just for 2 reps, kind of feel it out, and then work your way up to 100% kind of all out. Because again, these braking forces are so forceful, especially with a little bit of assisted load, and especially if they're getting more comfortable with just the movement pattern and such a focused drill, that they're going to have some pretty high outputs and experience some pretty high kind of eccentric and braking forces. So start submaximal, 50%, work your way up to 100. And when it comes time to actually test it, this is going to be all out and just attack it. Run in as fast as possible and slam on the brakes as hard as possible. So how to set this up in your software? Very cool, very simple, where it's just these 3 variables, or 4, and I'll explain what kind of each of them mean, and hopefully this will get some light bulbs as to how simple this is to collect. So we're actually going to start with the direction, and this is any linear type exercise. So the 1080 Sprint software knows just to measure one direction at a time. So the direction is set to assisted, so it's only going to worry about when the athlete is running towards the machine. The start condition is auto, so only when they break a certain speed and a certain distance, then it'll start tracking. So the coach does not have to hit, start whenever they start going. The machine will just know when they start. And then the finish condition, or when the machine stops tracking, is also on auto. So if the machine knows that the athlete should be running towards the machine and it's only going to be assisted, well, as soon as the resisted starts, or as soon as the phase or the direction changes, then it'll automatically stop measuring. When they walk out, the machine isn't worried about it. And then when they start moving and when they take the 2 back pedals, it is all collected. And then the side, or that is what foot is in front during the start, you can break down how much force kind of each leg is contributing during the entire kind of run. So those 4 variables, and very simple to set up. So the data and what you actually get from it, you have the curve, and this is a smooth curve, so kind of average from all the steps and the peaks. They accelerate to a top speed. The dot is where they hit their top speed, and they decelerate to 0 speed. We get total time, top speed, 0 to 5, max acceleration, max deceleration, decel time, XL distance, and decel distance, and then total distance. So very simple metrics. We're just measuring time, distance, and the change of those things, the rate of change. But to simplify this even more, there's only a handful of metrics that we really care about. So max deceleration, which is their best average deceleration over a half-second time window. We have the decel time, so how long it took them to go from their top speed down to nothing. And how far it took them to do that, that would be their output, what they produced. But that by itself doesn't really tell us much because it's all relative to the input, right? How much were they able to slam on the brakes versus how fast were they going? It's the same idea as a metric like an RSI, or a reactive strength index for a counter movement jump, a vertical jump. Well, it's not only how high did you jump, but how long did it take you to do it? So we have our main output metrics, and then it's relative to what the athlete inputted into that deceleration. So how to progress this over time and how to actually train deceleration so we know how to test it. Well, first, and in this order, first you start with coaching and cueing. So if you can keep the drill the same, 10 meters, 3 kilos, and you can get more intensity, you can get more output, right? A greater deceleration, less decel time, less decel distance, or you can have the same deceleration but more top speed going into it. If you can improve those things just by coaching and cueing and just telling the athlete to, hey, slam on the brakes even later or attack it even harder just by using your words without changing the actual drill, let's start there. Then the next variable to manipulate is distance. So going from 10 meters to 12 or 13 to 15, et cetera, et cetera. And the reason why we want to do distance next, to potentially have the athlete hit a higher speed and consequently more braking forces, is the athlete can self-regulate their speed. So same idea, just with going assisted in general, is we don't want to pull the athlete into speeds that they can't handle or aren't comfortable handling. So if you add 5 meters to the total distance, so going from 10 meters to 15, you would assume with more total distance, they can accelerate, they can speed up and hit a higher top speed going into the deceleration. But if the top speed doesn't really change, well, then you know that the athlete was kind of holding back because they're not comfortable entering the decel at those higher speeds. So let the athlete show you what they are comfortable kind of doing just by giving them more distance to potentially do it. And the last variable, if you coached and cued them to go really hard, and if you're at a long enough distance to where going even longer wouldn't really add more speed going into it, that's when you add load. That's when you go from 3 kilos to 5 kilos, where the machine is going to pull them harder and consequently increase their speed mechanically. Instead of them doing it, it is the machine giving them more force and more speed. But the key with this is only progressing one variable at a time. So once you've maximized everything from your coaching and cueing, then add distance. And once you've reached a long enough distance, then add load. But even if you go from 10 meters to 15 meters, and then you've kind of maximized that, well, add load, but also go back to 10 meters and kind of restart the process, right? So those are the 3 variables to manipulate. Only manipulate one at a time, and be conscious that these things are all connected. So like I said, if you're going to add load, well, decrease the distance so they can get familiar with that new load. And the best practices is although this is part of chain of direction, you don't need a chain of direction belt to do your ADA test or just to train your deceleration. So use a regular sprint belt and then just turn around and make it as tight as possible. So the clip is on the athlete's hips. So it's going to minimize kind of the bouncing when they're running. So the data will be as reliable as possible. Versus a chain of direction belt, the reason why it's a little bit bigger in circumference is so the rings and the carabiner can rotate as the athlete rotates. But in a deceleration, they're just going one direction, so you don't need to turn or worry about having a bigger belt. Next, have some familiarization, trials, sessions. Again, it's that on-ramping idea where just because you can and will be going all out, you don't have to do it right away. So you can just start just having a whole session, just going from 50 to 60 to 70%. And then, this is an awesome foundation to test next time. So no rush getting into the all-out decelerations. And last, keep the protocols, or more so how you coach and cue it, as consistent as possible. Because the last thing you would want is where you test half your team, you just say, hey, run towards the line as fast as possible, stop and decelerate. And the second half of the team, you literally say, I want you to slam on the brakes at the last possible second. That could change how the athlete executes or does an ADA test, and they could get a little bit better deceleration just because they know, I have to slam on the brakes. So when it comes time to actually test it, less is more when it comes time to kind of coach and cue versus kind of training itself where you're just trying to hit the highest outputs possible. So what's next? We have an awesome 3-part webinar series on chain of direction that is on our YouTube channel, and those are the titles and the thumbnails of the videos. And just do it. There's only one way to feel what 5 meters versus 10 meters versus 15 feels like, and what the difference between 3 kilos and 5 kilos and 7 kilos. And one way to find, hey, what does one of your elite male athletes get on this test versus what does one of your elite female athletes get on this test for max deceleration, let's say. So that's how to set it up. That's how to think about it. That's how to coach and cue or not coach and cue the ADA, how to progress variables over time to actually train and develop deceleration. So go out there and make speed happen.